Hi, welcome to Chemical Equilibrium. This will have a little bit of precursor things and then we'll jump right into it. So, little prior learning quiz. Pause the video, just answer true or false, write them somewhere on your paper, and we'll come back and see what you think. Alright, let's see. Did you get these right? If not, that's okay. We're going to talk about them in pretty good detail. But if you did, then you're on the right path. So there's some glossary definitions here. I put them in here because they come up quite a bit. Just read through them, see if you kind of make sense to them. If you're in class, ask questions about them. That's what I'm here to help you with. So far, we've been looking at irreversible reactions, thinking of things that the reactants turn into products and the process can't go backwards. So things like burning and fire, you can't take the ash, put energy and all the gases back into it to make wood again. It just won't happen. Other chemical reactions are reversible. This is where the products can turn back into reactants under the right conditions. We see this with pH indicators, changing back and forth depending upon the pH. They'll change colors as needed. So, what is chemical equilibrium? This is when both the forward and reverse reactions are happening at the same time and the same speed. So in the beginning, if we had two different substances, we just called them A and B, you don't have any products, they're colliding at a very high rate. That means this reaction is going to start happening going forward. In the middle, A and B, those things are still colliding. C and D, some new products, are forming. And so the collisions between the reactants decrease because there's less of them. The amount of collisions with C and D increase because there's now more of them. So the rate of the reaction going forward is going to go down. The rate coming back is going to start to increase. When we reach equilibrium, the speed at which the reactants become the products and the products become the reactants is equal. The amounts are not necessarily equal, but the amounts that are there remain the same. So there's constantly reactants making products and constantly products forming the reactants again. So chemical equilibrium can't always be happening because one, we have irreversible reactions which don't have chemical equilibrium, and two, it's a process to get to a balance. Now, a regular chemical equation with coefficients with the lowercase letters and the capital letters are indicating elements or compounds would create this expression here where we would calculate some value for what's called K. We're not going to be going into that, but I just wanted to show you where this goes in case you end up going further in chemistry. Now, in this expression, we don't include solids and liquids, the states of matter. We include aqueous and gases because those do have concentrations. But solids and liquids do not have concentrations, which is a ratio between amount and volume. All right. So, where does this take us? When a chemical equilibrium reaction is at equilibrium, we can manipulate and change it to either shift towards the reactants or towards the products. This is what we call disturbing the system and stressing the system. So this can be done by changing concentration of reactants or products, changing the pressure of the overall situation, changing the temperature of the overall situation, or adding a catalyst to our situation. Let's take a look at how each of these are affected. So, for concentration. So, we need to think, what types of matter does a change in concentration affect? Well, it affects gases, and it affects liquids. When we think of increasing the concentration, when you increase the concentration of a substance, it will shift away from what is being increased. So, if we increase the concentration of barium chloride here, it would shift away from barium chloride and shift to the right. If we increased the concentration of NaCl, it would shift away from it and shift towards the reactants. Decreasing. When decreasing the concentration, it will shift towards that substance. So in decreasing NaCl, the shift will happen towards making more NaCl. If we decreased sodium sulfate here, it'll shift towards it, shifting towards the reactants. So just as a final example, if we decreased the concentration of barium chloride, right, then that would shift it towards that substance to where overall this would be made more of, this would be made more of, because we'd shift it, and this concentration would go down because we need to use NaCl and BaSO4 to make both of these. So this was our initial shift, this was our initial change, which shifted it towards the reactants, and this would change how much of this concentration there would be, because it would increase using up what's on the right. We're going to come back in part 2 to look at the other directions as well. See you soon.